All right, yesterday we left off. We were in the middle of setting up the table, as I call it, setting the table. We were coming up with the X and Y values for the graph, and we already had the Y values done, so we were setting up the X axis. All we got to do is now count by pi 6, so we'll pick up where we left off yesterday. 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, 6 pi 6. What comes next? Whoa, too thick. 7 pi 6, which doesn't simplify. 8 pi 6, which simplifies to 4 pi thirds. 9 pi 6, which simplifies to 3 pi halves. 10 pi 6, which simplifies to 5 pi thirds. 11 pi 6, which doesn't simplify. 12 pi 6, which simplifies to 2 pi. And 13 pi 6, which doesn't simplify. Okay, that's all we're doing is we're counting by pi 6 and we're simplifying as we go. You'll get good at fractions. You have to get good at fractions. Now remember, the rule is to have at least one negative one, so I'm going to come over here about the same distance. I'll call that negative pi 6, and I got room, so I might as well put a couple. I'll put a couple more. So minus 1 pi 6, minus 2 pi 6, which is minus pi thirds, minus 3 pi 6, which is negative pi halves. All right, once you get your X and Y axis all set up and labeled, now it's time to put the food on the table. The food on the table is the sahala or the chala. This starts as a cosine, so it's chala. There's no horizontal shift, so we start at a high point right there on the y-axis. So it's high, axis, low, axis, high, axis, low, axis, high, axis, low, axis, high, and then we finish up with axis. And then working backwards, we get axis, low, axis, okay? And then all we got to do is connect the dots with these quarter cycle intervals so that it looks symmetrical, okay? Concave up, increasing, concave down, increasing, concave down, decreasing, concave up, decreasing, concave up, increasing, concave down, increasing, concave down, decreasing, so on and so forth. And if you want, you can extend it a little bit past and put little arrows on it to show that it does go on. 1, 2, so we have 3 positive cycles, which is what the question said. 3 positive cycles, and we have at least one negative critical value. So there's the graph. Okay, that's it. That's it. Now, here's what I want to be able to do. Remember that we said sine and cosine really are the same graph. They're just shifted from each other. They're shifted from each other. You should be able to write a sine graph or sine equation for any cosine graph and vice versa. You should be able to write a cosine equation for any sine graph. So let's see if we can write an equivalent sine equation. What's going to stay the same? The amplitude is going to stay the same, which is the wave height. That's this distance here from the axis to the top. That's 2 units. And the axis to the bottom, that's also 2 units. It's going to be sine now instead of cosine. The b value is still going to be 3 because the period is still the same. It's still 2 pi thirds. Or pi, yeah, 2 pi thirds. The only difference is now we're going to have a phase shift. So leave a little space right there. Now, here's how we figure out the phase shift. If we want to write a sine equation, sine is sahala, isn't it? All we got to do is shift over to a point where we're on the axis going high. We have lots of places we're on an axis going high. I see at negative pi 6, I'm on an axis going high. At pi halves, I'm on an axis going high. 7 pi 6, I'm on an axis going high. And 11 pi 6, I'm on an axis going high. Okay? So here's what we could do. If I wanted to shift over to negative pi 6, I would have to put a plus pi 6 right there in my horizontal shift. Because plus pi 6 actually moves the graph which direction? Remember, it's opposite of what it appears, right? So if you see x plus pi 6, that actually means left pi 6. If you wanted to shift over to pi halves, you would have minus pi halves. And if you wanted to shift over to 7 pi 6, you would have minus 7 pi 6. I'm not going to write any more, but any one of those 3 would work. X plus pi 6, x minus pi halves, or x minus 7 pi 6. Okay? Once you have the graph with all of your critical values labeled, it's very easy to write an equation in terms of the other sinusoid. Could we even write another cosine equation that would give us the same graph? Let's see if we can write another cosine equation. F of x would equal, let's use blue here, no, silver. F of x is going to be, the 2 is going to stay the same. It's still cosine. It's still 3, but now I got to shift over to another cosine point. Cosine starts high. We have 2 pi thirds starting high, 4 pi thirds starting high, 2 pi starting high. Let's shift all the way over to 2 pi. Let's start high at 2 pi. All I'd have to do is put what? Plus 2 pi or minus 2 pi if I want to shift over to the right? Minus 2 pi. Yeah, it's the opposite, right? Because it's inside, it's opposite. So if I put x minus 2 pi, that'll shift my graph all the way over to 2 pi. Let's verify. We wrote several equations of the same graph. Go to your Minnesota calculator, if you will. Minnesota calculator. Everybody go to your Minnesota calculator. Play along here. Or unless you want to stand up and get a yellow one. Uh-oh. My Minnesota link didn't work. Are they onto us? Did they catch on to us finally? A problem occurred? Oh, there it is. Woo! I was getting worried there. We shut down the Minnesota calculator website. I get emails all the time from other teachers who actually watch the videos on YouTube, and they all ask where I get this calculator. They all ask for the Minnesota link because it's a godsend, really. And you know what I do? I say for $100, I'll give it to you. Yeah, yeah. And then I say, just kidding, and I send them the link. Uh-oh. We got a server error. Yours is working? Shoot. Well, you know what I was going to do? I was simply going to graph this and y. Oh, there it goes. There it goes. All right, let's do this. Let's graph. We're in radian mode, right? We're in radian mode, so go to mode. Check it. We're in radian mode. Go to y equals now. Type in 2 cosine of 3x close parentheses. Let's go to our window now. Go to the window, and let's go from negative pi halves, because that's our leftmost point, negative pi halves, all the way to 13 pi 6 for the x max. Now for the y min, y max, let's go negative 4 to 4, because the calculator uses the top and bottom to write with. If I hit graph, I should see something similar to what we have, right? Does it look similar to what we have? Yeah, so we know we graphed ours correctly. Now, here's the truth, all right? If I type in any one of these 3 equations that I have, it should trace over the top. If I do it in y2, let's try it. 2 sine of 3 parentheses x, I'll do the first one, plus pi divided by 6, close, 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 close. It's red, right? It should trace right over the blue. Are you nervous? You think it'll work? I'm kind of nervous. I don't want to hit graph. I'm scared. I'm scared. I'm also just kidding. I knew it was going to trace right over the top. It has to. Math works, baby. Unless I typed it in incorrectly. Let's do one more. Let's do the other cosine one we did. I'm not going to do it in black. I'll do it in fuchsia. 2 cosine of 3 parentheses x minus 2 pi. Get way over there to 2 pi. Close, close. Are you nervous? I'm not. Fuchsia, baby. Or pink, whatever it is. How many different equations are there of this graph? Bless you. Infinitely many. Yeah. All you got to do is get over to a coterminal angle for the same trig function, or offset it to the right point where sine is on the axis going up, and then any of those coterminal angles. All right. Questions on example 5? All right. Now that one was pretty easy because we didn't have a phase shift. Look what we're doing on example 6. Sketch at least one cycle now, instead of 3, of this graph. Find and show the new sinusoidal axis. Okay, let's talk about what this is doing. What is the 3 going to do to this function? Just in terms of stretch or compress, vertical stretch, by a factor of 3. The minus pi halves moves it what direction? Right pi halves, and the minus 2 moves it down 2. Okay. So if we come off to the side and we collect our A, B, C, D, A, B, C, D, P comes next. These are specific for our sinusoid now. What would be the amplitude of this function? What's the wave height? It's 3. Yeah, that's your A, absolute value of A value. We're going up 3 from the sinusoidal axis, down 3 from the sinusoidal axis. How many cycles are we going to see between 0 and 2 pi? What's the B value? The B value is implied to be what here? 1. Yeah, it's implied to be 1. So we're going to see 1 cycle between 0 and 2 pi. Once you find B, come down and find P. What's our period then? It should be 2 pi over B, right? Which is still what? 2 pi? If we're going to see 1 cycle between 0 and 2 pi, the period's 2 pi. So I didn't change the period on this one. Now for the C, instead of equal signs, I said yesterday I like to put colons because I like to give myself directions. Instead of saying C equals pi halves, I'm just going to say right pi halves. And then for D, I'm just going to put the sinusoidal axis at y equals -2. That's what I always do for the D value. I just list the sinusoidal axis. It is down 2, but that's what the sinusoidal axis is. Okay, so here we go. Let's go ahead and start sketching our graph if you want. Here's the y-axis. Here's the x-axis. Looks like that. I go to my D value first. If I'm going to do my vertical axis, I got to come down here to -2. -2. And then I draw in a dotted line. We have a new sinusoidal axis, okay? Now here's how you can figure out the range of your function. Okay, it's going to oscillate between the high and the low. How high above -2 does this graph oscillate? How many units? What did you say? I didn't hear. What's the wave height? What's the amplitude? 3, right? So from -2, it's going to go up 3 units. So up 3 from -2 is 1, 2, 3. I hit a high point of 1. And then I go down 3 units, 1, 2, 3, to a low point of -5. What's the range of this function? I'm going to put the range over here. The range is y epsilon, -5 to 1. -5 to 1. Now that's another feature that we can always get. Watch this. The range is always going to be your D value minus the absolute value of A for your low point, and D plus the absolute value of A for your high point. You don't even need to graph it to find the range. I could ask you a multiple choice question where I say, what's the range of this function? And you're just like, oh, D minus the absolute value of A, D plus the absolute value of A. Okay? Now that's the easier of the two axes to set up. Here's what we're going to do for our x-axis. Notice I have a phase shift. Whenever you have a phase shift, here's what you need to do. You need to make a rough draft x-axis. A rough draft x-axis. Here's why. Eventually, we're going to be shifting this thing over into values that are brand new. They're not critical values. So I don't want to see any values on the x-axis except the critical values. So here's what I'm going to do. Before a phase shift, I go from 0 to 2 pi, right? And then that gives me pi and pi halves and 3 pi halves. Those are my original critical values. Now, if you want to come to the left one, that would also be negative pi halves. Let's give ourselves at least one negative one. Those are the original critical values. What am I doing shift-wise now? I'm moving it right, pi halves. Now, this is the first one we've seen where we're shifting it, so we're making it very, very easy. All I'm doing is I'm shifting it over one critical value, which makes it very, very easy. So pi halves is my new y-axis. And where's my first critical value after pi halves? Is it still pi? Yes. Is the next one still 3 pi halves? Yes, I'm essentially picking this up and moving it over one click and sending it right back down into the existing critical values. Okay? That's not always going to be the case. So that we get in the habit of making a rough draft axis. So I can actually set up my axis now by just saying, okay, there's pi halves. I moved it over from 0. 0 is still going to be a critical value. Pi halves is a critical value. There is my new y-axis. So I draw my new y-axis. So I basically have my new x-axis, which is the sinusoidal axis, and I have my new y-axis, which is pi halves. Now notice what I've done here. I've established this distance between consecutive critical values. On your graph, whatever that distance is, you need to maintain it the best you can. Okay? You could just eyeball it though. Eyeball it, eyeball it. As long as it's reasonable, I won't count off. If you put them too close together or too far away, you're not going to get credit. Now, it only said to graph at least one cycle, so we only need 5 critical values, and one of them at least has to be negative. So I think I'll stop right there. Now we got to go through and label the rest of them. Let's count by pi halves. 1 pi halves, 2 pi halves, 3 pi halves, 4 pi halves, 5 pi halves, 6 pi halves is 3 pi, 7 pi halves, so on and so forth. Counting backwards, I got 0, negative pi halves, negative 2 pi halves, and I can add more if I want. Got it? See what we did there? When you sketch by the Sahala-Chawla method, you're always going to want to show your new x-axis, which is the sinusoidal axis, and your new y-axis, which is the shift. Because the Sahala-Chawla method, that first letter in Sahala and Chawla always corresponds to the new y-axis. It always starts at the new y-axis. So what did this one end up being? It was a sine function, so it's what? It's Sahala. So I have to start on the axis and go up. So let's go ahead and put the food on the table then. Here's my new axis point. See it right there? It's the intersection of the x and y, the new x and y. So it's axis, high, axis, low, axis, high, axis. And then working backwards, the next one would be low, axis, high. You have to be very detailed, but I'm teaching you how to construct this from the ground up, so it shouldn't be that difficult. If you do it the same way every time, the way I'm telling you, you'll be set up ready to answer any question that I may ask. So I extended past the endpoints a little bit and put arrows on it. That's it. That's at least one cycle. It's actually 3 cycles or 3 1/4 cycles. And we have at least one negative. So there you go. All right. Let's go ahead and write an equation now in terms of cosine. Okay? Let's write an equivalent equation in terms of cosine. The amplitude is still going to be 3. That's still the wave height. Instead of sine, it's going to be cosine. The b value is still going to be 1 because that affects the period. The period doesn't change. The only change is the phase shift. It's still down 2. The only change when you change it to cosine is the phase shift. Now, for a cosine graph, remember, cosine is Chawla. So to write an equation for a cosine, all we got to do is shift over to our favorite high point. Just shift over to your favorite high point. Does anyone have a favorite high point showing? We have 3 of them showing, don't we? Pi, good. Let's shift over to pi. Let's shift over to that pi. If I'm going to shift over to the right, would it be x plus or minus pi? It would be minus. If I want to shift it to the right, it would be minus. In this case, would it be the same if I put plus? Would it work if I put plus as well? Yeah, because if I put a plus pi, I'm shifting over to the left, the negative pi. So here it would work plus or minus pi. That's not always the case though. So let's just say if I shift over to the right, it's x minus, not x plus pi. And there you go. We can keep doing this all day long. I can write another sine by looking at another axis going up. I can write another cosine by shifting over to any one of the other 2 pi's. I think you get the general idea. These 2 graphs, if you sketch them on your calculator, are going to give you the same graph. I don't think we need to verify it on the calculator this time. The first time was enough. Now we trust our work. Okay, So why did we do a sacrificial or a rough draft axis? Because we had a what? We had a phase shift. Okay? So we do a rough draft axis to make sure that we get our critical values all nicely found, and then I can transfer them to my graph. All right. Questions on example 6? All right. It's Friday. What do you say we do one more and call it a week, huh? All right. Next idea that we're going to talk about is what to do if you have a negative in front of the function. Okay, let's look at this one. This one's kind of a mess, right? I can spot the parent function right away, can't you? It's cosine. So it's some modified chala, but it is not in standard transformation form, is it? It is not in standard transformation form. So that's our first task. So let's write it as f of x equals. The one in the front should really get kicked to the back, shouldn't it? That's your d value. So I get negative 1/2 cosine, parentheses, leave the inside blank for right now, and put a +1 at the back. Remember, on the inside, that's where most of the work is going to need to be done, because I need to do two things on the inside. Number one, I need to have the x term first, and it is, so that's good. The x term needs to be first. But I need to have the coefficient of x, whatever it is, factored out from both terms. Is that done right now? No. So I need to factor the 4 out from both terms on the inside. So I need double parentheses. That's going to give me an x plus what? What do I get when I factor out a 4 from pi? Pi fourths. Muy bien bien. Pi fourths. Now we've got it. Now we've got it. Okay. Now notice we have a negative here. What is the negative going to do to this graph and any graph? It reflects it. This reflects it, remember, across the x-axis, which is your sinusoidal axis. And it has to be done before any shifts. Right? Multiplication has to be done before addition or subtraction. So here's the easiest way to take care of reflecting something across the x-axis. All you have to do is switch your highs and lows. Watch this. If you have the graph of sine that looks like this, and you reflect it across the x-axis, it looks like this, right? So there's negative sine of x, and the red is positive sine of x. All you have to do is do this. The axis points stay the same, don't they? When you reflect something across the x-axis, the axis points don't change. But what happens to the highs and lows? They switch, don't they? So on sine, the high point becomes a low point, and the low point becomes a high point. So it's axis low, axis high, axis. Axis low, axis high, axis. So you have these bizarro twins to Sahala and Chala. If there is a negative in front of sine, it becomes negative Salaha. Oh my gosh. Negative Salaha instead of positive Sahala. Now, do you have to remember negative Salaha? Please say no. No. All you have to remember is that Sahala, when it's negative, makes the highs and lows do what? Switch. That's the easy thing to remember. Don't remember another name. Okay? Now, it also works the same thing for Chala. So if you have Chala, which is positive Chala, the highs and lows will switch. And you end up with a bizarro twin called negative Klahal. What a name, right? Klahal. You don't have to remember negative Klahal. Just remember for Chala, when it's negative, the highs and lows switch. That's all you have to remember, and it makes sketching it a breeze. Watch, let's try it out. Let's go ahead and list our A, B, C, D on the side here. A, B, C, D, P, and R. Ooh, I'm adding R to the list, aren't I? Yep. What is the amplitude? What is the wave height? 1/2. Good. Yeah, it's positive 1/2. Okay. Now I'm going to put a little note to myself there because it's negative. Then I'm going to flip H and L. I'm going to flip the highs and lows. All right, how many cycles do I see between 0 and 2 pi? 4. That's going to change my period. So immediately I jump down to p, and it's 2 pi over 4, which simplifies to pi halves. There's my new period. I complete one cycle between 0 and pi halves. For the c value, it's going to be left pi fourths. And for the d value, the sinusoidal axis is at y equals 1. It's up 1. That's where the sinusoidal axis is. Now, can we find the range? Sure. The range is your sinusoidal axis minus the amplitude. That's 1 minus a half. And your sinusoidal axis plus the amplitude. Okay, let's see what that gives us. That gives us 1 minus a half, which is a half, and 1 plus a half is 3 halves. There's your range. Nice. Sinusoidal axis. If you know what we're doing here, it's easy to find the range. Sinusoidal axis is the middle line. You go down the amplitude for the low point, up the amplitude for the high point. Okay? All right, now, do I need a sacrificial x-axis? Do I have a phase shift? I do. My phase shift is, my phase shift is pi fourths left. So here's what I'm going to do. Here's my rough draft x-axis, my RDXA. Here's 0. Here's not 2 pi, but pi halves. I go out the length of one cycle, which is the period. 0 to pi halves. Half of pi halves is pi fourths. Half of pi fourths is pi eighths. Now, even after the shift, pi eighths is my quarter cycle counting interval. Pi eighths is still my quarter cycle counting interval, even after I shift it. So this would be 1 pi eighths, 2 pi eighths, this is 3 pi eighths. And if I go back, that's negative pi eighths. And if I go back again, that's negative pi fourths. There's my sacrificial axis. This is before the shift. Before the shift. Now I look at the shift. The shift is what? Left pi fourths. So everything is going left 2 critical values. See that? So it's still an easy problem, relatively speaking, because I get to use the same marks. I'm just moving everything over 2 clicks, 2 critical values, and now negative pi fourths is my new y-axis. See that? That's nice. There's going to be a time shortly, I guess next week, where we have to make new marks. Ooh, that gets kind of gross. All right, let's go ahead and create our graph then. There's your x-axis. Now, because you found your range is everything slightly above the x-axis. You can actually draw your y-axis a little bit lower than usual because everything's going to be above. That's why we find the range. It helps us with our graph. All right, let's get the high and low points. Here's the low point of a half. Here's the middle line of 1. Here's the high point of 3 halves. So I'm just going to label it like that. And then at 1, I have my new sinusoidal axis, like that. All right, now the x-axis. As soon as I know 0 is still a critical value, so as soon as I put down my first mark, I have established my distance between successive marks. So now I got to go back that amount and back that amount again, and there's my new y-axis, which is at negative pi fourths. This is negative pi eighths. And then I just label the rest of them. Let's draw them first. 1, 2, 3, 4. I'll do 5. And I just start counting by pi eighths. 1 pi eighths, 2 pi eighths, 3 pi eighths, 4 pi eighths, 5 pi eighths, 6 pi eighths, so on and so forth. Now, notice I didn't write down 4 pi eighths. I didn't write down 6 pi eighths. What am I doing as I write them down? I'm simplifying. Yeah. If you can't do that in your head, practice or go off to the side and simplify. Because all I want to see on your final graph are your simplified critical values. All right. Now we've set the table. Now it's time to put the food down. We got our new x and y axis. This function was a what? It was a cosine, but it was also a negative cosine. All right. Now cosine, remember, was chala, but because it's negative, my highs and lows flip. So instead of starting at a high point, I have to start where? I got to start at a low point. So I'm going to start at a low point right here. Okay, and I got low, axis, high, axis, low, axis, high, axis, low. And then I just connect the dots with these quarter cycle arcs that are all symmetrical to each other the best I can. There we go, and there's your graph. All right, now the last thing we're going to do, since that was a negative cosine, let's go ahead and write two other equations. Let's do a positive cosine. If I'm going to do a positive cosine, it's positive 1/2 instead of negative. Cosine, it's still a 4. The only thing that's different is the phase shift. It's still +1. So for a positive cosine, I need to shift over to a place where I start at a high point. Remember, positive cosine starts at a high point. Where's your favorite high point? 0. 0 is a high point. Do I need to put x minus 0 if I do it at 0? I could, but it's not even needed. If I want to shift over to cosine, I don't even need those extra parentheses. I could just say it's 4x and then say +1. Yeah. Or you could shift over to pi halves and have x minus pi halves. All right, now let's do it for positive sine. Positive sine is going to be positive 1/2 sine parentheses 4 x plus or minus something +1. Again, the only thing that differs when you put in a sine is the phase shift. For sine, it's Sahala. You got to be careful with sine because you can't just go to your favorite axis point, can you? There's two ways to go from an axis. You can go up or down. Positive sine starts on an axis and goes what? It goes up. Where's your favorite point where you're on an axis going up? I spy several of them. Negative pi eighths, 3 pi eighths. There's 2 of them. Which one you want to get over to? Let's get over to negative pi eighths. Good. If I'm going to get over to negative pi eighths, is it plus pi eighths or minus pi eighths? Plus. Yeah, it's the opposite of what it appears. Congratulations. We're done with the week. And we got 4 minutes to spare. What a real treat that was. 4 minutes to spare. All right, any questions? This is what we're doing the rest of this section. And then we're going to quiz or test next week over this. And your free response is going to be one like this, but one like you haven't seen just yet. It's going to be one where we have to make new marks for the x-axis. It's going to be kind of gross. But we're kind of building up slowly to that. All right, that's it. That's all I got. We got through example 7.